Hello, welcome to calculating the PM. Okay, first thing we want to do with curve sketching is a first derivative. Okay, so to analyze, etc. So the first derivative, f prime of x. This isn't a bad one to do because the 5/3 times 3 becomes 5. X to the, when we subtract 1 from that, we subtract 3 out of 3, right? 2/3. Minus, okay, 15 halves times 4/3. Oh, come on, arithmetic, guys.
60 over 6 is
10. Yeah. 10 and then x to the 1/3. Now, you're going to want to do sign analysis on this. That means we always take the smallest degree. Now, a negative sign would make it easy to decide, but which is the smallest degree here? 1/3, right? So we take out the 1/3. Or do we take out the 2/3? I don't know.
I'm going to guess 1/3.
Yeah. What happens though when we take this out? Yeah, okay, well. And the number 5. Okay. What are we left with here? Well, 1 for the number. X to the? Yeah, that's what I was just thinking here. Yeah. But this still, it's easier to operate. Then minus 2, and that's it. The x to the 1/3 x. Okay, this we can work with. That one not so easily. You could have actually, but now we've got to put this in a little bit of sign analysis. And part of the sign analysis is doing the critical numbers. When does this give us a 0? I guess I'll do it like this. The critical numbers. You know that you set the derivative equal to 0. F prime of x equals 0, right? And you set this, well, if this expression equals 0, then you either have 5x to the 1/3 equaling 0. What would have to be the x value of that? 0. X equals 0. Or 8. Good, you figured this out. And you were thinking? Cube root of 8 is 2. 2 minus 2. Okay. Good. Now, if not, put x to the 1/3 minus 2 equals 0. Move the 2 over to the other side, then cube both sides. But if you could see it, why would you bother doing it the long? Okay. Then, we're going to do some sign analysis here. So my factors from f prime are 5x to the 1/3, then x to the 1/3 minus 2. Where do I get zeros from those? I get them at 0, 8. Is there any restrictions on the domain, by the way? The original function, yeah, you told me. You got your, that's Randy's, okay. Is there any restrictions on a cube function? No. Okay, so then, we just toss in our zeros. 5x to the 1/3 gives me a 0 at 0. If you put in anything that's to the left of 0, what do you get, positive or negative? Negatives. Cube root of -1 is -1, for example, so you get -5. The positives in this zone and this zone. Okay? And then, 8. I get a 0 at 8. If I put in numbers larger than 8, I get positives. Okay. If I put in numbers smaller than 8, cube root of 1 is easy to test, or 0. Negatives. Yeah. Never changed, though. Okay, so this means overall this function goes from first derivative being positive to negative to positive. Now, just so that you have a rough idea what this looks like without curviness, this goes up. I don't need the arrow on this. I guess up, down to 8, and then up. I don't have any idea what the y values are, but I do know that there's a maximum at x equals 0 and a minimum at 8. Now, and I have a rough idea of what the graph looks like. So, you do this, and then you say max and min, relative max. At, well, that's it, x equals 0. What is the, here, so I plug in 0 into which function? The derivative or the original function to find the ordered pair? The original function. And 0 minus 0. And why is that a relative max? Since switches signs. Since f prime of x switches signs from positive to negative. Then, relative min occurs at x equals 8. And when you plug 8 into the original function, I've got it worked out here. Negative 24 is what it can be. Just because our time is short. And that's a relative min since f prime of x switches signs. It's very tedious doing this every time, but I want you to do this automatically so you never lose marks from me or from the AP peoples. Okay. There's our extrema. Also, on an AP exam and on my exam sometimes, if you ever see justify your answer, that's what this means, since f prime of x switches signs, or some explanation. The sign analysis we do over here, that's not enough to justify your answer. You use that to just clarify your own thinking, and then you can answer it. Maxes and mins, okay, good. Then we do the second derivative, and we can find the curviness, the concavity of this, right? So, you have a choice here. You could use this form of f prime of x, the first derivative, or this one. Which is easier, this or the first, to do a derivative on? This one here, I'd say so. Then you don't have to use the product rule. So I choose the easier one to work with. And I'm going to go with f double prime of x. I'm going to look at my notebook because I can't see that anymore. Okay, the derivative of 5x to the 2/3 is 10/3 x to the negative 1/3. And then it's subtract, is it? Yeah. 10 times a third, so 10/3 x to the, what was it? Negative 2/3. Okay. Then we do the old factor root. Take the smallest of them. And the 10/3. You know what? I'm going to just say right now I'm setting this second derivative equal to 0 to find out possible inflection points, right? You could do that right there, and x to the negative 2/3. When I do that, I got just the letter x. Tell me what I got for an x. X to the 1/3. Subtract 1. We can work with this, right? Now, where is this expression either undefined or 0? Possible inflection points, eh? 0. I'm going to check with 0 is undefined. However, is x equals 0 allowed in the domain of the original expression? Yes. So we can still, we have to look at this. It's just undefined within this expression. And then the other one is 1. That's a possible inflection point. we do some sign analysis. So on the side, I'll do it here. With those two factors, 10/3. I only put the 10/3 there because I want to know the sign, and it's positive 10/3 is being multiplied. X to the negative 3. Then the other one, x to the 1/3, subtract 1. Put them down at 0 and 1. 0 actually gives me undefined as far as this is concerned. We got to use that as a dividing line. It isn't an asymptote, so maybe I'll just remove this here, because it makes it look like the other line is an asymptote. So, undefined there, but anything greater than 0 gives me a positive. What about less than 0? Put -1 into that expression. -1 is not. What does this mean? Okay, and somebody sees that it's positive, but I'll just explain here too. 10 over x to the 2/3 is what this really means. 10 over 3x to the 2/3, right? That's what the negative means on there. That means take the, I'm going to put -1 into there. Take the cube root of -1, which is -1, and then square it, it's positive. You guys buy that? Okay. So this is positive, and then right here it's nothing for that. Then we have 1 giving us a 0. Anything higher than 1 be positive. You can see this, 8. Cube root of 8, 2, okay. Anything less than will be negative. So what do we got here? We have a negative, negative, positive. And since it's not broken up, the concavity doesn't change at 0, does it? And 0 is an allowed value in the domain. So it's really concave down on, I don't know, I'm running out of time. Since the less than 0, we'll leave it at that. Concave up. On 1 and up. Since the second derivative is greater than 0. So there is an inflection point at 1, since the second derivative switches signs.
Hello, Belford. This is your president of SRC speaking. I have a super important announcement for you. We are here to announce what the house team's prize will be. That's right, folks. We know what the house team's prize will be. The beginning of the house team's prize, whatever grade wins, you will get an entire week full of prizes. That means Monday to Friday near the end of the year, you'll get an entire week full of prizes.
Tuesday, you get a candy
And the final
cane.
prize will be a pizza party for that whole grade. Also, just a reminder to please bring donations for the food bank. Any non-perishable items will do. Thank you.
Oh, if we win, we get that.
So, we've got to figure this out here in 5 minutes or less. Ooh, goody. Now, this is a sketch where with this function, we got to just consider this. Now, this function, I don't think you can look at one of these functions. You guys don't. Do you have any clue what that would look like before we started? Something wavy and wooby. Woovy and wavy. I have no idea, is what you guys are thinking. The other function, you have a pretty good idea what it's going to look like. That's why we skipped that one for now. So we do our ordered pairs where we want x-axis, be careful. The y-axis, other than y equals 0, I'm not really too concerned so you don't make tick marks on it. But we have zeros and ones that are important in 8. You know what I'm going to do? Well, I'll just keep my 8 in here. I don't really have to do this to scale. -1, 1, and then 8 over here. What happens at 0? You guys remember?
It switches from increasing to decreasing, there's a relative maximum.
Relative max at 0. It goes from increasing to decreasing. And at 8, it starts going back up. Now, does this concave up biz? I'm gonna switch to this pen here. 1 and -9 halves. -9 halves is like 4.5, -4.5. Okay. So this is my 1 and -4.5, right? What's my min again? 8 and -24, was it? Yeah. So I'm not drawing this to scale, so I'm just going to call this 8 and -24 here. And my 0, 0 was my maximum, right? Concave up after 1, concave down before 1. I think this is pretty easy to figure out now. What does it look like? Scoop it above, right? So, I'm thinking concave down this way. Oh, what did I do wrong here? I guess I didn't figure out where the 0 is from the original expression, did I? Whatever, though, it looks like this. I don't have time right now, but it goes on. I'm not sure. You'd have to go back to the original expression, factor it, factor the lowest x, right? And figure out what that 0 is. What did I think? Well, it's about 125 out of 8. It's 15 and 6.625. So it's off there. If we had more time, I would have made us do it, but we don't. Okay? Now, from an equation, if you didn't have your graphic calculator, you should be able to do something like that. You can see tomorrow should be a work class, and it will be. Start working tomorrow. Okay? Well, you can start working tonight. You got that. Yep. I would have.